Radiation is the heat transfer from one place to another without necessarily affecting the intermediate medium. Transfer of heat without affecting the intermediate medium. Thermal radiation occurs in a vacuum without a material medium. The amount of radiant heat depends on the temperature of the emitting body. Very hot objects produce both radiant heat and visible light simultaneously, e.g. filament of bulbs. Heat transfer by radiation is faster than that by conduction, since conduction requires material medium, while radiation does not. Properties of radiant heat. The radiant heat is electromagnetic in nature. It can be reflected, then it causes heating effect in objects that absorbs it. Let us now look at an experiment that can be done to demonstrate good and bad absorbers of heat. We compare absorption by dull black surfaces and shiny surfaces. So we have the dull black surface and a shiny surface. The candle flame must be halfway between the surfaces in order to get good results. So we have two pins, pin 1 and pin 2, which are attached to the shiny and dull black surfaces respectively by use of wax. The observation made from this demonstration is that the pin attached to the black surface lid drops, whereas the one on the shiny surface remains undisturbed for some time. explanation to this is that though the amount of heat received by the surfaces is the same, black surface absorbs more heat than the shiny surface. Dull black surfaces are therefore better absorbers of heat. We can also carry out an experiment to demonstrate good and bad emitters of heat. In this case, we need to set up the apparatus as shown in these two diagrams. In order to get good results again here, equal volumes of hot water in tins A and B must be taken note of. Water in the tins must be at the same temperature, initial temperature. In this case, we are using a temperature of 80 degrees centigrade. While taking temperatures, one should start at the same time and for both tins and be done at regular intervals. The observation made here is that after some time, Ts is greater than Tb, implying that blackened surface loses heat at a faster rate than the shiny surface. The conclusion we get from this is that dull black surfaces are also better emitters of heat. And generally, we say that dull black surfaces are good absorbers and emitters, while shiny surfaces are poor absorbers and emitters of heat.